We did arithmetic sequencing earlier this year. I just want to remind you of what that was. So we had like 1, 3, 5, 7, and we decided we added 2 each time. Basically, it was doing the slope, okay, or the rate of change. So geometric sequencing, same type of stuff, except for now we're going to be looking at exponential things. So let's look at it. It says a pattern of numbers that begins with a non-zero term, and each term after is found by multiplying the previous term by a constant r. Okay, then that constant r is called the common ratio. And to find that, you divide the two terms. Okay, so here we go. All we're going to do is we're going to take 144. We're going to divide it by negative 432. And when I put it in my calculator, 432, I'm going to get negative 1/3. Now, we have to make sure that it works for all of them. So negative 48 over 144. So I'm going to take 48 divided by 144. And again, I get negative 1/3. And then last, I'm going to take 16 and I'm going to divide it by negative 48. And that'll get me negative 1/3. So my common ratio is negative 1/3. Then over here, I'm going to do 16 divided by 12. When I divide 16 and 12, now hopefully you know that 4 goes into both of those numbers, so you get 4/3. Then we would do 12 over 8. 4 goes into both of those, 3 over, oops, not 4, 3 over 2. And then this last one, I do 8 over 4, and I get 2. Now, are those exactly the same? No, it is not a geometric sequence because there isn't a common ratio. Okay, so now we're going to look at this one. So I have negative 0.7, nope, yep, negative 0.7 over 0.07. Did I do these right? Yeah, this is the one I just did wrong. You take 0.07 and you divide it by negative 0.7. And when I do that, I should get negative 0.1. And then I take negative 0.007 and 0.07. And I'm going to get negative 0.1. And then last but not least, 0.123 over 1, 2, and this one's negative 0.1. So my common ratio is oops, I forgot the negative also, negative 0.1. And that's how you figure out if you have a geometric sequence. So now let's look down at this one. Sometimes they look like this. All this means is the term. So first term, second term, third term, fourth term. And all we're going to do to see if it works is 20 over 8. If I do 20 over 8, I get 5 over 2. If I do 50 over 20, I get 5 over 2. And you always want to do all of them because sometimes 125 over 50, let's see, 25 goes into the top one 5 times, 25 goes into that one. It does work, so the ratio is 5 over 2. Sometimes it doesn't always work though, so you do have to be careful. So this one, it wants to find the next 3 terms. So it's already telling you that it's a geometric sequence. Now you just have to decide what the ratio is. So 16 divided by 64. That will get me 1/4. So the next 3 terms, so I'm going to take 1 and I'm going to multiply it by 1/4, and I get 1/4. Then I'm going to take 1/4 and I'm going to multiply it by 1/4, and I get 1/16. And then I'm going to take 1/16 and I'm going to multiply that by 1/4 and get 64. So those are my next 3 terms. On this one, I am going to take 729 and I'm going to divide, no I am not. I'm going to take 243 and I'm going to divide it by 729. 243, oops, that's not 243. I can't believe I'm doing this. 1/3. So I'm going to take 81 and I'm going to multiply it by 1/3, and I'm going to get 27. I'm going to take, oops, I should do a different color. 27 and multiply it by 1/3, and I'm going to get 9. And then I'm going to take 9 and multiply it by 1/3, and I'm going to get 3. Okay, this one. 44, negative 44 divided by negative 4 is going to get me 11. So I'm going to take negative 484 and multiply that by 11. When I take that and multiply it by 11, I'm going to get 5324. And then I'm going to take 5324 and multiply that by 11. I'm going to get 58564. And I'm going to take 58564 and I'm going to multiply that by 11. And I'm going to get 644204. And those are the next 3 terms. Oh, no, they're not. They need to be negatives. I forgot to put, oops, try that again. These all should be negative. There we go. Sorry about that. So this one, 12 over 8. If I simplify that, I'm going to get 3 over 2. So I'm multiplying by 3 over 2. So I'm going to take 27 and I'm going to multiply that by 3 over 2. Did I do that right? (27 over 18). 9 goes into that 3 times. Yeah, I did it right. Just making sure. Just making sure. So I multiply that and I get 27 times 3 divided by 2, and I'm going to get 40.5. And then I'm going to take 40.5 and multiply that by 3 over 2, which is 1.5. 60.75. And, oops, different color. 60.75 and multiply that by 1.5, and I get 91.125. Okay. Awesome. So the next one. Now we need to write the nth term of the sequence. That means that we need to come up with an equation, a formula. So the nth term, a sub n, of a geometric sequence with the first term is a sub 1 and the common ratio is r, is given by the formula. And this is our formula. Okay? And sometimes you'll see it written as this. A sub 1. You may see it written like that, but it's the same exact thing. So first things first, our a value is equal to 512. Our r value is 256 over 512. And I think I know what it is off the top of my head, but we want to make sure 1/4. Nope, 1/2. So I would have messed that up. So it's a half. So I'm going to take my a sub n equals 512 times my r value, which is 1/2, raised to the n minus 1. And that's our equation. So we're going to do the same thing over here. And I'm going to take 243, oops, different color. 243 divided by 729. Didn't we just do this one? Isn't this one 1/3? Oh, that's my r value. My a value is, my a sub 1, I should say, is 729. So I take a sub n equals 729 times the ratio 1/3 n minus 1. This one. Oh, I didn't read all the way. Sorry about that. So it wants us to find the 11th term. So we're going to take the 11th term. We're going to change that. I'll even change the color. It's not going to be a sub n anymore. It's going to be a sub 11 because that's what we're trying to find, equals 512 times 1/2, and then it's going to be 11 minus 1. So I'm going to put that into my calculator. 512 times 0.5 raised to the 10th power. And I get, oh, interesting. A sub 11 equals 1/2. Raised to the 10th power times 512. Yep, both ways I did it. Comes out to 1/2. This one, it wants the 8th term. So a sub 8 is going to equal 729 times 1/3 raised to the 8, oopsie daisy, minus 1. So a sub 8 equals, and I'm going to take 729, and now this one, make sure you do parenthesis 1 divided by 3, close parenthesis, raised to the 7th power, and you will get 1/3. Okay, so next, we're doing the population of North Dakota is increasing more quickly than other states. In 2011, the population was 685,242 and has been increasing by an average of 2.5 each year. And this trend continues to determine the estimated population in 2030. So our starting, where are we starting at? So our a sub 1, we're starting with 685,242, and our ratio for this one. Now be careful on this one because we're actually if I wanted to find what is that? The 19th value was, I could do that. But this is going to want 1 plus r on this because I want the total population. Okay, I want the total population, not just what that factor is. Sorry, my brain had stopped for a second. So a sub n would be 685,242, 1.025 raised to the n minus 1. Now, it wants the 20th year. So that's going to be, oops, I didn't mean to do that. I want this color. 685,242, 1.025, and 20 minus 1 is 19. So we're going to plug that into our calculator. And we're going to get 685,242 times 1.025 raised to the 19th power. And that's going to get, in the 20th year, 1095462.251. Okay? And if we were rounding, we would take off that part. And there we go. 1,095,462. Okay? Then, bounces. A rubber bouncy ball is dropped from a height of 5 feet. Each time the ball bounces back to 85% of the original height. Now this is going to be the same thing as that last one, but it's decreasing. So it's going to be minus. Okay, so the rate on this is going to be 1 minus 85%. So that's going to be 0.15. Is that right? Okay, the original height was 5 feet times, I may be wrong on this one, raised to the, nope, it wants the 85. I lied. Yeah. So a sub 6 is going to be 1.89. A sub 10 is going to be, let me put in 10. 0.898 feet. Okay. Sorry about that.